this Camel Quarkus thing, firstly we should understand what Camel is and what Quarkus is. So firstly I will go through the details of Camel. So Camel is Apache Camel. It's a upstream community project. It's a very popular project which has been active for past 10 years. Okay, and it is very active project. Okay, and it's a Java based project. And the importance of this Camel project is it is used for integrating different endpoints. Okay, so different protocols. Like if you have a FTP endpoint, and if you have a web service endpoint, or if you have a JMS messaging endpoint, so it can so Camel will help you to integrate those components. So yeah, Java is already there. So and the other languages are as well. What special you get with Camel? So Camel provides the tested, proven components which are built in Java. Uh, uh, the benefit of those components are they are already tested. They have gone through they have been tested by many customers, and they have gone through load testing. So with those components, you just have to provide the configurations like URL, parameters, number of connections. So after providing these parameters, you can connect to your different endpoints speaking in different protocols. So firstly, we will go through a presentation. Then we will be also focusing on a small demo as well. So what Camel is, it is actually an implementation of enterprise integration patterns. So enterprise integration patterns is a very popular book written by Gregor Hopp and Bobby Wolf. So what this enterprise integration pattern is, what they did, like they went into different enterprises, they listened to the customers, and after listening, they created they created patterns which are helpful in enterprise, like content based router, like splitters, aggregators, okay, and sequencers. So that this book is all about the enterprise patterns. So what Camel writers did, they went through this book, and in Java they implemented it actually. So Camel is an implementation of enterprise integration patterns. Okay. So what Camel provides us? Camel provides us the enterprise integration patterns like splitters and aggregators. So let me provide you an example. Okay. So it happens like in the enterprise enterprise solution, we have a big file. Okay, and we want to split it into multiple components, and based on some values, we want to send it to different components or different endpoints. Like if we want to send it to a web service, and some part of XML we want to send it to a SMTP server. Another part we want to send it to a SFTP server. And the last part we might be interested in sending it to a IBM MQ. So this splitter is a component, is an enterprise pattern which has already been written by Camel. So you don't need to write it again. Okay, we just need to reuse those patterns which has been provided in Camel. So there are multiple such patterns, and there are components as well. Okay, so there are components as well, and right now if we this large collection of adapters components for legacy. So right now there are around 300 components connecting to different endpoints like SAP, Facebook, Twitter, LinkedIn. So you don't need to write any, from scratch. You don't need to write any Java code. You just need to provide URL, your username, password, or your some authentication key. That's it, and you are okay to connect to it. And it provides different DSL language as well. So if some people, developers, they have very good experience, they can write in Java programming language. But some people, they don't have much experience. They are comfortable with XML based. So you can write in XML based as well. And GUI based language is also there. So there are different DSL language, domain specific language, to write the flow, the integrations. Okay, So as I said, these components, this is a 10 years active project. So there is a strong unit test. So this Camel support different formats as well, and there are toolings as well. Okay, toolings means for Java developers there is Eclipse, there is JetBrains IDE, okay, IntelliJ IDE. So similarly, we provide plugins. Okay, so the Apache Camel provides plugin that can be installed in Eclipse, that can be installed in IntelliJ, and it can be in Visual Studio as well. Okay, so there are plugins available for quick development. Now, yeah. So if Java, if there are Java developers, they can easily relate this. Okay. So what we see here, it's a route builder. So we are creating an integration route. You can say it's a camel code. So route, generally in camel terminology in Apache Camel, we say it as a route. So from it says active MQ orders. Okay. If we see here, it's active MQ orders. So active MQ orders means it is consuming, it is processing the data from the active MQ. Okay, active MQ is a JMS, we can say JMS provider or JMS vendor. It's a messaging product. So, and there is a choice. Then we have this EIP. Okay, when the header is something like customer rating, then send it to IBM MQ. Then IBM MQ is again a messaging vendor. So whatever we are consuming from active MQ, we are based on some headers, we are sending it to IBM MQ. Otherwise, if this header is not there, if this header doesn't match with gold, send it to a FTP server. Okay, so this then we are logging it. It's simple. You know, you just need to write a log statement, and you can log the complete body. Dot order ID means from body it will select the order ID. Okay, and at last send it to the store order. Send it with the help of Camel MyBetis, that is MyBetis API. You can send it to store order table in your database. So that's it. So in these few 5 to 6 lines, we are integrating with IBM MQ, we are integrating with FTP server, we have integrated with ActiveMQ, and we have integrated with iBetis as well. So 4 or 5 components. We don't have to write any final clause to close any stream. We don't have to be concerned about try and catch. So these components, these ActiveMQ, this IBM MQ, these are already being written in Apache Camel. So that's why I'm saying there are such 300 components. Okay. So moving to next slide, if someone is interested in XML, so this is the same thing which can be written in XML format, like from URI ActiveMQ orders, then based on switch case, that is choice, we are sending it to WMQ, IBM MQ, otherwise we are sending it to a FTP server. And finally, we are sending it to iBetis. Okay. So this was a quick overview of Camel. There is definitely a lot, but my concentration here is on Quarkus as well. Okay, what Quarkus provides you? It's a new buzzword. Okay, Camel has already been there for 10 years. Quarkus is something new, and what Quarkus provides you, we are going to focus here in this area. Okay, so if we consider like the traditional way of deployment, we generally talk about cloud. Okay, so why we moved to cloud? Because the monolithic mode, there was a monolithic applications which were quite huge, and maintaining them is a big task, because you know if there is a developer, if he left the company, so new developers will find it pretty difficult to work in monolithic application. So documents would also be very lengthy for that monolithic application. So there comes then the microservices were there. Okay, so in microservices, the size of that monolithic war or jar was if that monolithic jar was of 100 or 200 MB, then microservices came to around 10 MB or 20 MB. Okay, then after microservices, we have a new term that is known as functions or serverless. Okay, so this function and serverless means it is native executable. So when I'm talking about Quarkus, I'm talking about serverless functions. Okay, so the size again, it is quite reduced. Okay, and it is built on top of it is ahead of time compilation. Okay, so you might so we will discuss something about GraalVM as well. Okay, which is a new offering from Java, which is specifically built for the cloud, for the containers. Okay, so this Quarkus is typically built for the your containers, for OpenShift environment, for Kubernetes environment. Okay, so now the problem with Java was always the problem with Java was that it takes times to load. Okay, so if you have a Spring Boot jar or monolithic jar, so it will take time to load. Okay, so application might start in 10 seconds, 20 seconds, or even 30 seconds. It depends on the size of your work. Uh, but when we talk about Quarkus, so this has been reduced a lot. Okay, so the application, the Java application, will boot within seconds. Okay, within seconds. So this we will check in demo as well. So within seconds, your application will be booted up. Now, what the benefit of this? Because if you are working in cloud or containers, let's say your application crashes and you have a live traffic. So if your application starts in your 10 seconds, so within 10 seconds you will be having many fail requests. It might not be acceptable in your in the enterprise solution. So if your application starts in microsecond, that's what we are looking for, and this Quarkus solves that purpose. Okay, it's an extension of current Java framework. So, if we talk about Kubernetes, we talk about the core API or replica sets, the statefuls, and the deployment. Then, as we move up in applications, we have this Camel and Quarkus, singleton microservices, batch job. So these all are application level. So the core things, the core Kubernetes APIs are still a replica set, and these are application level. Okay, Quarkus and this Camel. So we will be discussing this part, topmost part here. Okay. So yeah, the problem with Java, like many people say, Java is slow. Okay, why? Because earlier when we talk about Java, so we were talking about like Java is portable. It can be run on Linux machine. It can be run on Windows machine. It can be run on any OS. There was just a need of JVM. Okay, so virtual machine was needed. But when we go to containers, okay, but when we talk about containers, that portability cannot be defined for Java, because now the Node.js application or reactive applications, they were quick enough. They were having an upper hand in comparison to Java, because Java was somewhat slow at boot time. Also, the first response, like if your application has started, if there is a web service, the first response from that web service is bit slow. The other response are very fast. There is no issue about the other request once that first request is processed. So this Quarkus resolves both of these things: the response time, the first response time, and the boot time. Okay. So this is the density problem of the Java. Okay, that was like if you see this Node.js application, you built in Go language. So you can have multiple Go language deployed in one node. So similarly, Node.js as well, you can have multiple Node.js application deployed in your one node. Okay, one node means, when I say it's a one node where your containers are deployed. And when we talk about Java, so there were less number of Java applications that can be deployed in one node in comparison to Go language, application built on Go language and Node.js language. This is a density problem of Java, which is still relevant, but with the help of Quarkus, which is something new. Okay, we will be able to resolve all these problems. Yeah. So as I said, like when we talk about containers, we talk about when an application crashes, what will happen. So with the help of Quarkus, the scale down time will be reduced. Okay, will be reduced, and even it can scale to zero. When we talk about serverless, the serverless concept is when there is no traffic, your application shouldn't consume any CPU resource. So it will scale to zero. Okay, there will be no application installed if there is no request in your containers. So as soon as there is any request, your application will start. And as we said, with the help of Quarkus, the boot time will be fast. So within microsecond, you will be have an application serving the incoming request. The benefit is you are saving your money, because if your application is up all the time, that is consuming the CPU resource, that is consuming the memory resource, and mostly the cloud. When we talk about cloud, our applications are deployed on Azure and AWS, so we have to pay for those resources. So with scale to zero, with serverless concept, we will be able to reduce that money, that cost. So what is Quarkus? So Quarkus is typically built for Kubernetes and OpenShift. Okay, and this Quarkus is built on top of GraalVM and OpenJDK hotspot. Okay, so it is this Quarkus is built on top of GraalVM and OpenJDK, and specifically it is for Kubernetes and OpenShift environment containers. So if we see here the memory footprint. Okay, so the memory footprint for Quarkus, if you see here, 0.01 second. Okay, so first response time for a Quarkus request is very less. It is in microseconds. While if you talk about Quarkus in JDK, it is somewhere 1 second. While if you talk about a normal Java application, it could be in 4 or 5 seconds. Okay, so the first thing is Quarkus plus runtime as your Kubernetes. Second point is Quarkus plus Java. Okay, it is running as a plain Java. Even then, the response time is reduced with 1 second. The traditional applications we see that is more than 4 seconds. So this is it's a normal REST request. So when we talk about REST plus CRUD, so CRUD is when database is also involved. So then a traditional application might have the first response time as 10 seconds. Just note, here I'm only speaking about the first response time. So once first response time is over, the applications are loaded. The second request is served more faster in each application. It could be traditional as well. Okay. While when we talk about Quarkus, it will take only 2 seconds. And when we talk about Quarkus plus Kubernetes, it will take microseconds. Okay. And the memory as well. So memory here, when we talk about traditional applications, memory could be around 136 MB. So a normal application, normal web service will take about around 136 MB of your memory. So while Quarkus with Java, okay, with OpenJDK 11, it will take around 73. While when we talk about Quarkus, it will take less than 50 MB. So the memory utilization is less, and the first response time is very fast. That is the advantage you get with Quarkus. So now I will be showing you a quick demo so that you get a better idea. Okay. So let me show you like this Quarkus. We can easily build an application here with the Quarkus. Okay, so you just need to go to this quarkus.io. Okay, if you see it is written Supersonic Subatomic Java. Okay, what does it mean? Java is very fast and it is very small. That is the meaning of Supersonic and Subatomic Java. So start coding. If you just click on start coding, it will start building up a project for you, a sample project. So now here you have to select the component, like which component you want to build application with. So currently it's a Camel Quarkus session. So I will be building Camel, okay, application. So it can be Camel core and anything like Camel, and let me show timer, Camel timer. So let me select a timer example. That could be easy. Yeah, camel timer. Okay, then I need matrices as well. Okay, so micrometer, it supports matrices as well. So I will have this as well. So once this is done, you just need to click on your generate your application. Okay. So once you download as a zip, uh, you have a sample ready. Okay. Do you see this thing? So this is done. So if I go to my download section, I will see here that this code with Quarkus, this zip is installed. Okay. So for this session, I have already this with me. This is Quarkus and Spring Boot. So I wanted to show you like the difference between the normal microservice which is built on top of which is built on Spring Boot runtime. So if you run this application, okay, so yeah, so right now if we see here, okay, this is a Camel Quarkus application. Let me increase the font. Okay, I hope it is clear. This thing. Okay. So right now I have a native jar. I have a Quarkus native jar already built. So let me show you how we run it. Okay. So in target folder, I have this Quarkus already running. So if so I just need to run it. Okay. So if you check here, the startup time. Okay. Startup time is let me see. Apache Camel started in 00 second. Okay, and when the application was started, so yeah, 018 second. If you see this, okay, so within microsecond the application was started. Okay, and if you notice here, it is not a normal Java file. Okay, it is not a normal Java. It's a native build. It's a native build. Like in Linux operating system, we have native build. So it is similar. So Quarkus is building a native jar file. I shouldn't say jar file. It's a native build. Okay, and I can directly run it with this command. I don't need to pass Java-jar, something like that. So that's it. So it is running, if you see, it is running in 0.17 second and 0.18 second. Now, let me run this. Okay. So this is running in 0.2 second. So let me tell you now the memory utilization with this. Okay. So what is the memory utilization? So this ps-aux RSS memory I am checking. Okay, so if I check, I am sorting with the RSS. If you see this, so RSS is around 38 MB. Okay, it is in bytes. So this is kilobyte and 38 MB. So only 38 MB this native build is utilizing. It is the runtime memory utilization. Okay. So now this is the native build. Okay, how we build this? Let me show you how we can build this. So yeah, so with this command, we build this. Okay, yeah. So with this command, mvnw package tnative. So tnative means it will build a native jar for you. Okay. So with this command, it will build a native build within the target folder, and I'm just running that. So let me remove this native. Okay, let me run this with the JDK itself. So still it's a Quarkus application, okay, but it is building on top of Java. So yeah, if you see here, it started in 1 second. Okay? If you remember last time when it was a native build, it was started within the microsecond, I would say, within a second. But it's a Java application. It is being Java application, and if you see, it is still Quarkus, but runtime is Java. Okay, and for that, the runtime was GraalVM for native build. For this it's a JDK. It is started in one dot. Now, if I check the uh, Java jar, if you see here, the memory is 160 MB. Okay, so it is 160 MB now. So this memory RSS is the memory actual taken in your RAM. So it is increased. Last time we saw that it was around 34 MB, 34 MB for the native build that is built on top of GraalVM. But when we run it as an OpenJDK, it is 160 MB. Okay.
So,
Now, yeah.
can we wrap up this session because we have time constraints?
Okay, fine. So that's it, guys. So if you run a Spring Boot application, it will take around 500 to 600 MB, and the startup time would be around 4 to 5 seconds, even more than that. That's it, guys. So that's all I had for this session.